So good afternoon, everybody.
Good afternoon, sir.
So title of my today's talk is Magnetically Separable Nanocatalyst, Sustainable Catalyst for Nitroaromatics Reduction. First of all, I am discussing the content of my talk. It includes general introduction, research work discussion, conclusion, list of publication, and finally acknowledgement.
Dr. Mahalakshmi, ma'am, someone wants to join this meeting. Jyoti Gaur is there. You have to admit so that she can enter the meeting. Can you see?
Can I start?
Yeah, wait, Dr. Tanmay, wait.
Ma'am, I have only 12 minutes. Between this time, I will
Wait, sir, wait. Ma'am, something is written on the right side, waiting to be admitted. Jyoti Gaur is there. She wants to enter this meeting. Can you see over there? You have to just click on the admit button, which is written blue in color. Ma'am, I have done it. Please take care in the future. Now, Dr. Tanmay, you start doing. Thank you.
Okay, madam. Thank you. So now very briefly, I am discussing comparison between homogeneous and heterogeneous catalyst. Basically, homogeneous catalyst present in single phase, whereas heterogeneous catalyst present in different phase. Besides this, in homogeneous catalyst, all atoms participate as active centers, whereas in heterogeneous catalyst, only surface atoms participate as active center. Homogeneous catalysts show high selectivity, whereas heterogeneous catalysts show low activity. But compared to homogeneous catalyst, heterogeneous catalyst can be separated easily, so cost of catalyst loss in high for homogeneous catalyst. So we need a material which can eliminate disadvantages of both the catalyst and include advantages both of them. In this situation, magnetically separable nanocatalysts can play an important role, as nanocatalysts contain much more active center due to presence of high surface area similar to homogeneous catalyst, and easy separation process using only magnet resemble them with the heterogeneous catalysis. Now, I am discussing why we select nitroaromatic reduction. Because wastewater of industries contain paranitrophenol, which is highly toxic and carcinogen in nature. Paranitrophenol harmful effect which is an important feedstock for the synthesis of various drugs in pharmaceuticals. Of photography, chemicals, polymers, etc. Now we have first prepared some homogeneous catalyst. Chlorofluorosalicylaldehyde will condense with the 2-aminoethyl pyridine. We first prepared a seed base, and this seed base will react with the copper chloride to prepare this homogeneous catalyst. Then we characterized this catalyst in different techniques such as UV, IR, and X-ray crystallography. From the UV absorption, we can see here both the complex at the 370 nanometer and for complex 1 and for the 383 nanometer for the complex 2. This is ligand to charge transfer transition. And from FTIR spectra for both the complex 1 and complex 2, we got IR band near about 1470 centimeter inverse and 1458 centimeter inverse. This is due to the skeletal vibration of the benzene ring, and this 1638 centimeter inverse and 1687 centimeter inverse is due to the imine bond from the seed base. And if we look at the crystallographic structure, here copper is coordinated with the NOO donor ligand from the phenoxo, pyridine, and imine nitrogen. So, symmetry related phenoxo and this chloride ligand. The geometry about the 5-coordinated copper can be best described in between distorted square pyramidal and trigonal bipyramidal geometry. Now, we have used both of these homogeneous catalysts for nitroaromatic reduction and observed complex one higher catalytic activity. I'm not showing the result here due to the time constraint, as one show higher catalytic activity. We used it for preparation of the magnetic separable nanocatalyst. For this, we prepared ferric oxide nanoparticle and modified their surface with isonicotinic acid. Then complex one attached on it. Here is the scheme. First, this is the scheme for the preparation of the ferric oxide nanoparticle, and here we attach the isonicotinic acid with oxide nanoparticle, and then this surface, and we this is our desired material. Next, we characterized our material in the different techniques such as FTIR, magnetic hysteresis study, powder XRD, and same and same image. From the IR spectra, it shows that at the band at 547 centimeter is due to the iron oxygen bond, and 1519, which is the presence of CMD present in the pyridine ring in the isonicotinic acid. And this 1629 centimeter in the imine one on the complex. So we can these are form. And we studied the magnetic measurement, and here ferric oxide, ferric isonicotinic acid, ferric oxide, and the complex were conducted at temperature. As almost 59, but after addition of the isonicotinic acid, it decreases, and after addition of the copper again decreases, and it ranges to the 3356 EMU gram. But the value is still within the range to get easy separation from the medium with the assisted external magnet. Next, we started power XRD, and to theta value for ferric oxide, we obtained 28.69 or 45 degree and 59 and 60 degree. All these values also present in our desired material. And this is all uniformity. And the same is iron oxide nanoparticle is really constant percentage of magnetic that average size 30 nanometer. Started the reduction of sodium borohydride. Here you can see we monitor the usual spectroscopy first. And first of all, the parameter panel was a band at near about 310 nanometer. But after the addition of the sodium borohydride, the band shifted at 395 nanometer. This is due to the formation of the phenolate ion. You can see the color here. Is the color is yellow after addition of the sodium borohydride. Then when we wait for the several minutes, this band is gradually decreases, whereas a new band is generated at least 300 nanometer. This decrease of the band is due to the conversion of the 4-nitrophenol to the 4-phenol. And here is the this plot is done the kinetics. I am not going to the details of the kinetics. Next, started with the different type of state, and we will here yield turnover and all are repeated. finally, this catalyst height, here is the result. This catalyst shows finally we investigated its morphology used. This is the same image, and it is from this image the morphology of the catalyst. And this is the provable mechanism, although the mechanism is not so properly explained by anyone. Just it is explained that the after addition of the borohydride, activate hydrogen is generated, and which is absorbed on the surface of the catalyst, and then nitrophenol is absorbed on it, and further hydrogenation is occurred in the N double bond O, this bond, and from this is this kind of intermediate, and after this the amine is formed, and it is displaced from the catalyst, and the catalyst is regenerated. Next, the conclusion of our work is that the detailed preparation of the procedure outlined for ferric oxide, isocyanic ketonic acid, copper nanoparticle catalyst. This catalyst subject is a comprehensive characterizing using FTIR spectroscopy, CMPM, and power XRD. Catalytic properties demonstrate the reduction of nitroarenes with sodium borohydride. Notable advantage of this catalyst include ease of separation, and this catalyst maintains activity without loss at least 5 cycles, and remarkable feature exhibit high activity at room temperature, highlights exceptional utility of the potential of this catalyst. And these are some recent publication of my publication. And finally, I want to acknowledge my university, Diamond Harbour University, for giving me the opportunity to do this type of research work, and also thanks to organizing committee ICCMEPR to invite me, and my students Rimpa and Rinku. Without their help, I cannot do this kind of work. I also very much thankful to Dr. Moduluta Sakla, Department of Chemistry, GB College, Kumar, Singh University, for collaboration with us. I also express my gratitude to Professor Devashish Das, Department of Chemistry, University of Calcutta, and Professor Ino Jagrando, University of Houston, for their guidance and support. And finally, I want to express my hearty love to my angel for his moral inspirations. Thank you.
Myself, Dr. Anita Padasalagi, faculty in the Department of Physics, Rani Chennamma University, Belagavi. Here I am presenting my research work, highly efficient biomass-derived carbon quantum dots as a green photocatalyst for the degradation of dyes. These are the contents of my presentation: introduction, synthesis, characterization, and implementation as a photocatalyst. And finally, I am giving conclusions. This is a overall graphical abstract of my research work. So all of you know that carbon quantum dots are the new frontier in the field of carbon nanomaterial family, which have been extensively studied from its discovery in 2004. After that, biomass-derived carbon quantum dots offers more advantages because of that biocompatibility, biodegradability, low toxic, low cost, as well as their eco-friendliness. So in this regard,
excuse me, ma'am.
Yes?
Your slide is not moving. Your slide is not moving, ma'am. Please check it. Just click on the second slide.
Yeah. Now I am in second.
Click on the second slide.
Yeah, I am in second slide.
No, it's not moving, ma'am. You can please reshare that one.
Now is it moving? Now I am in second slide.
Yes, ma'am.
Okay,
It's moving.
Okay then. Shall I continue with fourth slide?
Yeah, you can.
Okay. So biomass-derived carbon quantum dots offers several advantages that biocompatibility, biodegradability, low cost, low toxic, eco-friendliness. So, and they offer some more advantages in various fields, photocatalytic, electrocatalytic, in biomedical applications. In this regard, here you chosen Bombex mori silk cocoon as a natural biopolymer, which consisting two proteins, particularly that silk fibroin and the sericin. In a silk industries, during the separation of the silk fibroin from the sericin, this lost one quantity of water was used, and this water is discarded as a waste after separation. And annually, for each year, close to 4 lakh tons of raw cocoons produces 50,000 tons of sericin as a waste, and which contaminates the environment. And this is the structure of sericin, which consisting 18 amino acids in that carboxylic acids there. So, and it is also rich of carbon and nitrogen. In order to convert this waste into valuable material, here you chosen sericin as a starting material to prepare the carbon quantum dots. So, this is experimental methods. There are two parts. First, isolation of silk sericin. The silk cocoons is cut into small pieces and submerged into 100 ml of distilled water, and which is consisting 1 ml of acetic acid in it. And after acid degumming approach, there is a water insoluble silk fibroin is separated from this degumming solution, and it is the left solution is referred as a silk sericin. This is what you are using to prepare the carbon quantum dots. This silk sericin is obtained by heating the degumming solution at 100 degrees Celsius. After collecting silk sericin powder is carbonized at a different temperature, about 150, 200 to 50, 300 degrees Celsius for a particular time period of 2 hours. And the respective materials are referred as a S1, S2, S3, S4, respectively for the 150, 200, 250, 300 degrees Celsius temperature. And here, further, we have studied the material characterization of these prepared nanoparticles. So from the transmission electron microscopy, you can observe that the particles are spherical in shape and they are uniformly distributed. And here also find out the average size of the particle is about 5.3, 6.7, 8.4 and 9.7 nanometers with the increasing the carbonization temperature. So one thing here you have to observe that with increasing the carbonization temperature, there is an increase in the size of the particles, which is further confirmed from the XRD pattern. So now here there is a peak at 21 from the XRD pattern. Observe the peak at 21, which is associated with the sp3 state of carbon. And when you move from the S1 to S4 sample, it means when you move from the temperature 150 to 300 degrees Celsius, there is increases the appearance of a peak at 26, which is indicates the formation of sp2 carbon core, which is further confirmed from the Raman spectroscopy, and it is a very important tool to study the carbon-based materials. For these carbon quantum dots, you observe the two bands where the D and G band, where the D band indicates disorderness of the material and G band indicates the degree of the graphitization. Here the intensity ratio of the D band to G band goes on decreasing with the increasing the carbonization temperature. It means there is a increases in the degree of graphitization with increasing carbonization temperature. This is all about the core study. Now we have to study the surface chemistry of these carbon quantum dots. From the X-ray photoelectron spectroscopy, observed that there is a presence of carbon, nitrogen, oxygen elements. So the carbon is because of carbon double bond carbon core, and nitrogen and oxygen is because of presence of functional groups such as amine, carbonyl, hydroxyl groups. So further, the optical from the detailed characterization, you confirmed that the prepared materials are the carbon quantum dots with a different size. Further, the optical properties of these materials are studied. These are the photograph of the synthesized carbon quantum dots. When it is dispersed in a distilled water, it is used like a colorless pale yellow, dark yellow, brown in color under normal light. When it is exposed to the UV light, will absorb the blue, green, yellow, orange emission under the excitation of 350 nanometers. So these optical properties were studied by using UV visible absorption spectra and PL emission spectra. This is the absorption spectra. Here there is two bands. This is associated. The bands around 200 to 250s are associated with the carbon core, and the 200 to 300 bands are associated with the surface chemistry of the carbon quantum dots. From the PL emission spectra, it is observed that the redshift in emission from the blue to orange around 420 to 560 nanometers. It is almost 180 nanometers redshift in the PL emission. This is consistent with the photochromic shift in the absorption spectra. So now this is all about the synthesis and material characterization of the materials. So now we have to look for the photocatalytic activity of the prepared materials. The photocatalytic activity of these carbon quantum dot S1, S2, S3, S4 are studied by using the two dyes, the crystal violet and rhodamine B. So those are the very they have a mutagenic and carcinogenic in nature, and they cause serious issues to human life as well as to the environment. So the degradation of such a dyes is very important to sustain the environment. So in that concern, we have chosen crystal violet and rhodamine B to check the potential, photocatalytic potential of the our materials. So here, for the this photocatalytic activity is carried for the carbon quantum dot S1, S2, S3, S4, and these are the absorption spectra for the crystal violet, rhodamine B, and it is carried for the 70 minutes. So from the degradation efficiency plot, you can observe here the S4 is showing good result as compared to S1, S3, S4. Based on this result, so went with a further detailed characterization, detailed study of this photocatalytic activity of particular carbon quantum dot, that is S4. So now here the this catalytic activity is carried for the 70 minutes. In the interval of 10 minutes, here the absorption spectra are recorded. So these are the optical images of the solution at 0 minute and 70 minutes for the crystal violet. It is for the 0 minute and 70 for the rhodamine B. So from these images, you can clearly observe that the carbon quantum dot S4 can degrade the crystal violet and rhodamine B in the efficiency of 97% and 71% respectively. So now it is very important to know that which radicals are involved in this photocatalytic activity. Either it is superoxide radicals, or it may be hydroxy radicals, or it may be electron holes by taking the scavengers such as benzoquinone, ethylene diamine tetraacetate, and isopropyl alcohol. So by adding these three, you can see this. There is a reduction in the efficient reduction in that photocatalytic degradation efficiency. So from this plot, I can say that the all three, that is hydroxyl, superoxide radicals, as well as the electron hole pairs, are involved in the photocatalytic activity of this carbon quantum dot S4. This is the mechanism how it is happening. So there is emission of carbon. There is a carbon quantum dots emitted for solar light, and after that, so what happens, there is the electrons which are present at the HOMO levels are excited to the LUMO levels, and respectively there is a creation of holes in the HOMO levels. For this photo excitation, there is a formation of electron hole pairs takes place. Some of the electrons are trapped by the defects which retards the rate of recombination, but some of the electrons are captured by the dissolved oxygen which produces the superoxide radicals, and some of the holes left in the valency band or the HOMO levels, they will react with the water adsorbed molecules, and they produce the hydroxy radicals. So these superoxide hydroxy radicals, as well as some electron holes are left in the HOMO levels, are act as active radicals, and they degrade the dyes, and this can be recycled. You can use this material again, carbon quantum dots recycling for the 3 times. So if you using some materials as a photocatalyst, it is very important to look for that repeatability and reusability. So here you can see, by conducting the 3 cycles, you can say that our material is showing good repeatability. And from this XRD pattern, you can see here, this is before photocatalytic activity carbon quantum dot S4, and it is after carbon quantum dot S4, after the photocatalytic activity. There is no any changes in the XRD pattern. It means it is showing that good stability for the photocatalytic activity. So the overall conclusion is, here you synthesized the carbon quantum dots using simple method with the green chemistry, and by varying the reaction condition, that is nothing but temperature of carbonization, your 2-napkin PL emission is achieved. Further, the prepared carbon quantum dots are systematically implemented for the photocatalytic dye degradation respectively with the promising results. So further, I would like to thank University Belagavi for providing me opportunity to work here. So, and also I would like to thank the Department of Science and Technology, Karnataka Science and Technology Promotion Society, for offering a financial support during this work. And I also would like to thank Karnataka University Dharwad to allow to do some characterizations there. So finally, by saying the conversion of waste into valuable material is beneficial for the economy and environment, I would like to say thank you. If there are any questions, you can ask me.
A very good afternoon to everyone. First of all, thank you so much, Research Review Publishers, as well as the Organizing Secretary of International Conference of Composite Materials for Environmental Protection and Remediation 2024. For inviting me for this technical session 1, basically on composite materials for environmental protection as well as remediation. Today I'm going to talk on the EcoNano. It's nothing but a development of the nanoparticles from the bio-waste, which can further utilize for the sustainable purpose in pharmaceutical and biomedical industries. In recent years, there is a development of nanoparticles and the utilization in various fields, starting from the biomedical to the cosmeceuticals, agriculture industry, as well as various industry, due to the inherent physicochemical and mechanical properties. There are several conventional techniques which are involved for the synthesis of the nanoparticles, but these conventional techniques also include the various types of toxic materials as well as non-renewable resources. Therefore, in recent years, the green synthesis has came into limelight to overcome all these developmental challenges of the nanoparticles. But however, the burden on global food security as well as limited resources create distress over the environmental sustainability. And in this context, EcoNano proposes a paradigm shift in the nanoparticles development by harnessing the bio-waste as a feedstock. So we can convert this bio-waste in the nanoparticles. So one way it can be manageable with the waste, as well as it's an eco-friendly approach to develop the nanoparticles, which are quite less or no toxic, as well as further can be utilized for several purposes. Our sustainable technology, which can further reduce the greenhouse gas emission, conserves natural resources and mitigates pollution, which can further contribute to the healthier planet and more sustainable future for future generations. Before going for deep into my presentation, we need to first understand the present problem. Throughout the world, there is a huge or enormous scale of the global food waste. If you look into the populated countries like China, India, United States, we can find that each year some 50 kg of food waste have been generated from the household waste. Apart from the food waste, there is also waste related to the hair. In a recent rising in India especially, we have seen that from 2020 or 2015 FY to 2020 FY, there is an increase of almost 123% of hair exports from India, which is having a lot of cost in the US $1 million. But again, in the country, there is a lot of waste which should be addressed or which should be managed. The question is, we need a solution for all this bio waste, especially the household waste. And this solution should address or should reduce the greenhouse gas emission. This should conserve the natural resources. This should also protect from the transmission diseases. And this should further utilize or manage this bio waste. Therefore, we need a solution. The first solution, which can be the management of the waste, and the second solution, we can have a good product from this waste. So we have selected the second option, where the bio waste, from that we can derive the natural products or nanoparticles, which can further utilize for several purposes. These are some of the application or utilization of the EcoNano. EcoNano is just a word which we have provided to synthesizing or development of our nanoparticles. These nanoparticles have been further tried for the cancer, arthritis, and other biomedical and cosmeceutical purposes till date, especially in the in vitro as well as in vivo model. Furthermore, we are looking forward to utilize these nanoparticles for the biosensors as well as for the diagnostic agents in several types of disease or disorders. These nanoparticles have also the probability to utilize in the various electronics and automobile industry. Furthermore, we have also trying with these nanoparticles in the forensic science to isolate the DNA or DNA fingerprinting, as well as the laboratory industry. In addition, in a recent time, there has been a tremendous increasing amount of nanoparticles utilization in the agriculture industry, and therefore, based on that yield value of the nanoparticle processing or the development, we can further utilize in the agriculture industry. As I have mentioned, till date, we have worked on 3 basic nanoparticles which can develop from the biowaste. The first one is a zinc oxide, the second one is a cerium oxide nanoparticles, and chromium oxide nanoparticles, which we have developed. The figures, what you can see is nothing but the high scanning electron microscopy or transmission electron microscopy morphological examination of those nanoparticles, and these are the application where we have till date further applied of our nanoparticles or EcoNano. Coming to the SWOT analysis of our EcoNano, these nanoparticles are sustainable. These are comparatively low toxic than the physical or chemically developed nanoparticles. These are effective in several types of biomedical as well as cosmeceutical applications. The main problem associated with the nanoparticles is the scaling up of these nanoparticles. The reproducibility is one more another challenge, and definitely along with that, the cost margin is a concern. These kind of nanoparticles can further be utilized for the various types of medical applications. It can be also utilized for the energy storage as well as the conversion. It can be further utilized for the food and agriculture sector. The present threats of this kind of nanoparticles are competition. The second is regulatory guidelines, because as said, there is no such regulatory guidelines which come into force, especially countries like India. And third is the acceptability by the people, because ultimately, even though these nanoparticles possess a lot of significant effect in vitro as well as in vivo models, even some of the clinical trials are also undergoing in countries like USA, China, Japan, and South Korea. But still, the acceptance by the people, by the patients are most important. And on that note, the acceptability is one of the major challenges in this kind of products or nanoparticles. The future looks bright with a sustainable nano world. By transforming this biowaste definitely into a valuable nanoparticles, these nanoparticles can catalyze a shift towards a circular economy, and which can further promote the environmental stewardship. Our nanoparticle or sustainable technology, which can reduce the greenhouse gas emission, conserves the natural sources where people are more rely into the natural sources such as plants, flowers, the fruits, the vegetables, etc., and which can also eliminate or mitigate the pollution, which can further contribute to the healthier planet and a more sustainable future for future generations. Definitely, at the end of the presentation, by concluding, I'm pretty much sure that we all are working for the planet, and our dedication to conservation as well as sustainable practices not only benefits the art but also inspires the others to follow in our footsteps, and therefore we can make a world of differences as well as healthier world. And finally, we would like to thank you on behalf of my team. I'd like to thank the Inipur University for providing the facilities as well as the intramural funds, as well as Department of Science Technology, the Science Technology Board of Research for providing the sufficient fund to do several research for this kind of work. Thank you so much.
Good afternoon, everyone. My name is Dr. Ashwani Sood, Associate Professor at Guru Nanak Dev University, Amritsar in Punjab. My topic of presentation is influence of some environment-friendly solvents and polymers upon the chemical and surface properties of surface active agents for their industrial applications. Now, what are surface active agents? Surface active agents are those which act on the surface of the liquid. They are normally called as surfactants. And when the concentration of these surfactants increase in the solution, they form micelle, they form aggregates, and those aggregates are called as micelles. In these aggregates, the hydrophobic part of the surfactant is inside, and the hydrophilic part stays outside the surface, as shown in this figure. Now, the concentration of the surfactant at which the micelle formation takes place is called as the CMC of this particular surfactant. It varies from surfactant to surfactant. What are the properties which affect the CMC of a surfactant? These are like the structure of the surfactant, what surface active agent, how long the hydrophobic chain is, additive, like any additive, organic additive or any other additive has been added or not, co-surfactant, is there any other surfactant present in the solution, as well as the temperature. What is the temperature at which we are going to work? So what are the various applications of surfactants? They are used for reducing the surface tension, improve the wettability of the surfaces, provide cleanliness, solubilize the hydrophobic oils, and stabilize the foams, modify the surfaces for their inter-particle applications. Now, what is the micellar behavior of surfactant in presence of polymer? The micellar behavior of suppose the anionic surfactant, sodium caprylate and cetyl platinum chloride, which is a cationic surfactant, can be shown like this. These are the structure of these surfactants and the polymer. They are very significant for the applications in paints, coatings, adhesives, detergents, and lubricants. Now, these are the figures which show the polymer. This is the surfactant, and this is the micelle. When the polymer and surfactant come close together, they interact, their hydrophobic part interact, and the hydrophobic part of the surfactant interacts with the hydrophobic part of the uh, polymer. And when the concentration increases, they form micelle around the polymer. And once the micelles are formed, some micelles are formed in the solutions also. So this is the saturation of the polymer chain. And this is how it is happening. This can be measured using conductivity meter or surface tension meter. This is the aggregation concentration at which the aggregation with the polymer starts, and PSP denotes the polymer saturation point where the polymer itself is saturated with the surfactant molecules. This is the viscosity studies which we have carried out in order to find out the concentration at which these points are achieved. The conclusion from these observations are that the aggregation concentration decreases, whereas the polymer saturation concentration increases with the increase in the amount of the polymer. The viscosity studies indicate the expansion of the polymer chain due to the electrostatic repulsions among the surfactant molecules. And most importantly, the interaction of the anionic surfactant is stronger as compared to the cationic surfactant in case of polymers. These work has been published in these two journals. Next topic which we have discussed, which we have studied, is the mixed micellization of two type of different surfactants. These are the two different type of surfactants which we have chosen. All are cationic surfactants, and this is how they interact. One type of surfactant interact with another one to form a mixture of micelle. Micelle means mixture of the two surfactants which aggregates. Now these mixtures are very important because sometimes one surfactant is not good enough to perform certain applications in medicines and dispersion sciences. So that's why we use two types of surfactants so as to reduce the effect of the other surfactant. These mixed mixes allow us to select the most suitable surfactant combination for the desired surface action and to reduce their harmful effect. These are the various interaction parameters which we have obtained using these mixtures. And from these observations, we have concluded that the mixture of C16 means carbon 14 and 16 mixture is useful for the applications, whereas other two combinations are not suitable for industrial applications. Next thing which we have observed is the suitability increases with the concentration of the longer chain length surfactant concentration. Then we have studied the mixed micellization of different type of surfactants which contain two hydrophobic part. These are the two hydrophobic tails which we have been synthesized and two hydrophilic heads of the surfactant. This is how they have been synthesized, with the diamines reacting with the alkyl bromides and heating in presence of ethanol and then recrystallization, forming this type of surfactant with longer chain. This is more important than other conventional surfactant because they have longer chains as compared to the conventional surfactant, so their applications is more important. So we have studied the micellization of these surfactants together. This is the two chain surfactant and this is a single chain. They form mixed micelles like this, and the conclusion from these studies include that there are favorable interactions between these two type of surfactants. These double chain surfactants interact more favorably with the polymer in comparison to the single chain surfactant. So these studies have been published in these journals. Then we studied the effect of various solvents on the mixed micellization of different types of surfactants. So this is the mixed micelles of two types of surfactants. One is double chain, other one is single chain. Here we have added alcohols in their presence. And then we have observed that the alcohols enter into the micellar structure. And these are the three types of alcohol which we have studied. And they enter the micellization structure and reduce the critical micelle concentration. These things have been used for the food industry, cosmetic, as well as coolant industry. Then we have studied the application of these mixed micellation in presence of glycols. The glycols do not enter the micellar structure, they stay on the surface. These are the two glycols which we have studied, and their applications have been found to be in emulsions and formulations as well as in paint industry. These are the various observations which we have made from the connectivity studies from these experiments. And we have observed that these are the conclusions. The presence of alcohols facilitate their activity, means increase their activity, whereas the enhancement is more. The increase in the activity is more in case of longer chain alcohols. Then the glycols reduce the surface action, and reduction is more in case of the glycerol, which is having 3 OH groups. These studies have been published in these journals. Then we have studied non-ionic surfactants with the ionic surfactant. These are the 3 types of non-ionic surfactants we have chosen. We have their hydrophobic chain and hydrophobic chain ratio. This is how they interact with the conventional surfactant to form the mixed micelles. And then these non-ionic surfactants have been found to be useful in food industry and bioseparations. The conclusion of this study is that the non-ionic surfactant exhibits stronger interaction with the ionic surfactant. The synergistic interaction means attractive interaction increase with the increase in the chain length, and the enthalpy change are positive due to the destruction of hydrogen bond around the hydrophobic part of the surfactants. These studies have been published in the journals, reputed journals. Then we have studied the micellar parameters of the Gemini surfactant, means 2-chain surfactant, using calorimetric method. This is how we have obtained. This is region 1 graph, region 2, and then region 3. From these 3 region graphs at different temperatures, we have obtained the delta H micellization, delta H enthalpy of micellization, and how much heat is being generated. And this is how the diameter, hydrophobic diameter, changes with the DLS studies, the size of different type of surfactants. Conclusion from these studies are the change in enthalpy obtained from direct calorimetric methods are same as those from the thermodynamic calculations. So experimentally determined delta H values are similar to that of calculated values. The entropy changes are positive, which decrease with the increase in the temperature. The size of the micelle increases with the chain length of the surfactant. These studies have been published in the following journals. Now, then we studied the volumetric studies in deep eutectic solvent. These are deep ionic liquid type solvents, where we have studied the density and measurements. These are the tables, densities, how the density change. Then the theoretical studies have been carried out. The theoretical studies show that the negative effects molar volume of the indicate the decrease in the volume upon the mixing of the 2 type of solvents. There are stronger interactions in case of choline chloride and as compared to that of the choline chloride amino acid, due to the higher value of interaction energy in case of choline chloride. These studies have been published in the following journal. Now here also we have studied different type of salts, and their studies are present here. ITC measurements have been carried out to determine the delta H values, and these are the various conclusions. These are the factors which affect the different types of salts, how they affect the CMC and the micellization behavior of surfactants. Finally, we have carried out the studies in presence of polymer like BSA, and their studies have been published. How the solvent affect the CMC of the surfactant. This has been published in the following journal. Now I'm thankful to the organizing committee of ICCMEPR 2024 for giving me the opportunity to present my work. I'm thankful to the Guru Nanak Dev University, Amritsar, for providing me the research facility. I'm also thankful to the UGC for funding. I'm thankful to DST PERS for providing equipment facility in our department. And finally, not for PhD students and MSc students. Thank you very much.
Good afternoon, everyone. Thanks ICCMEPR 2024 for this opportunity to present my research work in this August gathering, especially Madhuli Samam for inviting me to present my work. So first of all, I'll be talking about my university. I work in IIT Dimtu University. It is in Bhubaneswar, Odisha. I'm working as a professor in the Department of Chemistry. My university, though it is a private university, it is recognized by different accrediting agencies. We are the university, I think only private university who got the Institute of Eminent status. And we are also Tier 1 university by NBA. And we got 6th rank by NIRF this year. And we got A++ by NAC, and there are many more accreditation, many more awards and recognition by different agencies. So with this, I just introduced my university, and I request some of the researchers who are nearby, they can visit my institute and as well as my laboratory. So today's talk is on triboelectric nanogenerator. So I will be talking about what is the motivation why we started this kind of research. Actually, if you look at this picture, then very small amount of energy is required, like 1 microwatt to 1 milliwatt, even if 1 nanowatt energy is required for small IoT devices. So nowadays, if you look at any person, they will have a mobile phone and for chargers and so many things, wristwatch, all are battery operated. Means though they are the small batteries are there to operate those devices, and you know the batteries have a lifetime, small lifetime. After that, it won't work and it has been thrown to the atmosphere. This way, it is causing environmental pollution. But anyway, like last 2 decades, if you look at like any person, they will have number of electronic devices. Even if you can think of a dozen of electronic devices with them, so we can't avoid that. At the same time, the small batteries are being used. So we thought how to power these small electronic devices where micro or milliwatt energy is required. For that, we have started this kind of research. Though we know that, mobile phone, it required 1 watt, and similarly here the oven, like that require 1 kilowatt. Similarly, 1 gigawatt energy is required to power a city, and 1 terawatt energy is required to power a continent. So this way we can't provide that amount of energy, but a small amount of energy that can be generated from the environment to power these small electronic devices. So with this, we have started our research on triboelectric nanogenerator based on the triboelectrification and electrostatic induction. So this is long old technique or age-old experience, because when we comb our hair with a plastic comb, we have experienced the hair is attracted towards the comb. So by triboelectrification, tribo means the friction between the hair and the plastic comb, there the charge is generated, and the charge generated on the comb is negative, and the charge generated on our hair is positive. That's why there is an attraction between the hair and the comb. So this is a small example where we have experienced the triboelectrification. So with this concept, we have started thinking about how we can generate a small amount of energy we can be useful to power the small electronic devices. So here, for the first time, we have used GIP67. It is a metal organic framework to be used as a positive layer of the triboelectric layer. So GIP67 is synthesized by using cobalt nitrate as the metal source and 2-methyl imidazole as the linker, because in a metal organic framework, there is a metal and a organic linker. So it is a hybrid organic inorganic material, and which is basically, it is well known for it has ultra high surface area. And again, it has the combination of properties of inorganic as well as organic. So to use that benefit, we have used G67 as the triboelectric material. So this is synthesized by following a room temperature synthesis, and after getting the powder, we have coated over the copper electrode, and this S-type tank is designed by using a 3D printer, and plastic urethane is used as the source, and then on this the copper layers are copper tape is pasted, and on that the layer is formed by using the G67 particles. So this acted as the positive layer, and PDMS and Teflon act as the negative layer, because every time in the tank device there is a layer is required. Yes. Yes, anything? Okay, so that way the material is thoroughly characterized by using powder XRT, and TGA, it is thermally stable up to 400 degrees Celsius. And again, the roughness is very important, because when roughness is more, the friction will be more. So the roughness is measured by using AFM, and the roughness is 159 nanometer, and the surface potential is also equally important to understand whether our material is positively charged or negatively charged. So to measure that, we have used the KPFM probe, which is attached to the AFM, and it is available in our central research facility, and our material is positively charged, and the voltage is around 1 volt. Similarly, we have measured the surface morphology of our material by using APSM and TEM. In both the cases, this has dodecahedron shape, and we have measured the surface area, because surface area is very important for the triboelectrification or the energy generation, and our material is highly porous and it has very high surface area, and by using the BET analysis, we have measured that it is 1263 meters square per gram. And again, we have checked the, to see whether our material is properly synthesized or not by using FTIR. And here the peaks are mainly due to the organic imidazole ligand present in the material. Similarly, further it is characterized by using an XPS to understand the cobalt in which oxidation state it is present, and from the XPS spectra it is known that cobalt is present in cobalt +2 and +3 oxidation states. And here you can see the dodecahedron shape of the crystal is very nicely present by using the TEM analysis. And similarly, Raman is used to complement the FTIR to understand the other peaks present in the material. Similarly, the electrical performance is used by using a device where we can check the charge voltage time and voltage versus time. And here you can see as increase the linear, we have used a linear motor, and here by increasing the frequency, the number of the current is increased, but there is no changes in the voltage. And similarly, we have checked the current, the resistance with respect to resistance, and the maximum power output is 1.6 mega ohm with a load resistance of 10 to the power 9 ohm. So here you can see again we have checked the charging and discharging graph by using this material, and then directly I will be talking about the usefulness of this device, because when if we are doing any kind of research which does not have any implementation in our day-to-day life, I don't think that that research, though it is fundamentally very much important, but in in our society, like when India is a country with highly populated country and our economics is not very high, so it should have some social implementation or it has some practical implementation. But with this realization, we have tried to understand the gate pattern analysis by using this device. And gate pattern analysis is very important to understand the health assessment, and also in a massive in temple area or where there is a large number of people are gathered, there the gate pattern is very important to understand, and that way some of the incidents can be avoided. So with this understanding or with this realization, we have used the device in flip-flop and given to the children playing in a park. And then we have the score, the detection of that, the signal and the wavelet come from their movement. And here you can say this wavelet packet transformation. You can check the kids who are running and the kids who are sitting. The signal is different for both the cases. So this way, this device can be used to understand the gate pattern, and this way we can use for the health monitoring, as well as when the kids are playing, we can, if we are observing, then also we can be able to know that whether they will fall down or they are playing properly. Similarly, we have used to power up small electronic devices. Here, a calculator is being used to, the tank device is used to power this calculator. And here the robotic gripper, the device is used to use in this robotic gripper, because the surface is different. Just for example, the surface of orange and surface of apple is different, and this robotic gripper can recognize the surface of an apple and surface of the orange, and that can be used to sort it out these different objects. Here I'm just giving the example of orange or apple, but this robot can be utilized to sort the different materials in the shops or different vending zones. So here, just for example, we have used golf ball, silicon ball, and foam ball, and then this device is being used to measure the current with respect to time. And here you can see, in case of golf ball, the current measurement, if you will get the current density is less, and again it is very less in case of silicon ball, and again less in the case of foam ball. Means here I'm not talking about that how much current we are generating, but here I just wanted to say that the golf ball, silicon ball, and the foam ball, their surface roughness is different, their softness is different. By this way, the current generated is different. That way, though, this can be distinct. This is able to distinguish between the golf ball, the silicon ball, and the foam ball. So this way, the robot can be used to sort out the different type of materials in a shop. So this way, the manpower will be, the use of manpower will be less. So here, this is the video where the device is used to power up the wristwatch. And again, we have synthesized ZIP8, that was ZIP67, to use for the tank device. And here the application in a different way, we have used for the tilt table and powering small electronics. So small electronics, the same way it works. And here tilt table test is very important in medical, because when a person is fainted off so often, then tilt table test is very important to understand the stability, the blood pressure, and the related to heartbeat. So this can be measured by using our devices. Similarly, as you know, nowadays we are talking about circular economy. So most of the time, the spent catalysts are not being reused. So here we have used the catalyst which is being used in the petroleum industry to refine the petroleum, and then that catalyst is thrown away. So that MALI catalyst, NEMO catalyst, nickel molybdenum catalyst, we have derived the molybdenum from the NEMO catalyst, the spent NEMO catalyst, and we have used again to synthesize a molybdenum based MOF, and that has been again used to fabricate the device to be used to powering small electronic devices. And here we have used in a different way to monitor the punch repetition and during boxing. So in the 3 different materials are being used in 3 different devices to fabricate 3 different devices, and to be used in real life application to get monitoring gates to power the small electronic devices, and again to be used in the robots. So here again, we have used in the tiltable test and to monitor the ponds. So this is all about the today's talk. We have synthesized 3 different MOFs, especially one molybdenum-based MOF and 2 one cobalt-based MOF, and one other is zinc-based MOF. These are synthesized by using room temperature solvent-assisted method. Though there are so many different methods to synthesize metal organic polymers, we have chosen room temperature method. This is the easiest way, and these are used for the tank device as the positive material in each cases, because as you know that in tank devices in the tank series, this is basically dominated by the metals, polymers, and here metals are inorganic and polymers are organic. So here for the first time we have used a material which is made up of organic and inorganic. It is a hybrid material, and the output voltage is measured and the current is measured, and it is being used for powering the small electronic devices, and we have tried to understand the real life application. And I acknowledge my students, those who have worked for this work. My student Jay Kishan, Niharika and Vikas, they have worked, and this thanks to the funding agency DST Baroness and Minister of Mines, as well as my university, KIT Dimtov University, for this work. And my collaborators, Yashuke Amauchi and Professor Goejun Kim, who has helped me to understand the robotic application of our material. And thank you everyone for your patient hearing. And this is a small effort towards renewable energy, or to reduce the energy burden. And thank you everyone. And I just wanted to show some facilities available, our central research facility, because I'm heading to that facility center, and we have Raman, NMR, XRD, TAMS, and APSCM, AFM, spectrophotometer, CHN analyzer, and UTM, LCMS, and some are more facilities are in the pipeline to come. So I request you, all of you, to visit the Central Research Facility and our university. And thank you everyone.